Everybody see my screen okay? Good. Let's go ahead and review over. Excuse me. I was working the track hoe all weekend, and evidently I shook up some trees with pollen in them. So let's go ahead and get started on what I would call a review of the last class. And that's where we actually found the mean, the variance, and the standard deviation of a quantitative frequency distribution. Let's go ahead and make up one today to do. Let's go ahead and do 20 to 24, 25 to 29, 30 to 34, 35 to 39, and 40 to 44. And that is our classes: lower class limit, upper class limit, and the frequency. 1, 2, 6, 8, 2. Okay, now go ahead and write this quantitative frequency distribution. I want you to, number 1, find the class width. Number 2, class boundaries. Number 3, the midpoints. And number 4, find the mean, variance, and standard deviation. Because that basically is a test question. Find those 4 things. Let me remind you that I can't see you, no offense, but please pull your camera down where I can see you. Thank you. Give y'all a few minutes to do that. Mr. McDonald, which question are you talking about? Did you send them to me? You can unmute your mic if you want to. I mean, it is legal for y'all to talk. Okay. Just makes the class last 10 times longer.
No, I knew how to do them, but they were just very tedious.
Okay. Well, I'll have to look at them. I haven't even looked at them, so I don't know. I'll have to see what was so annoying about them. Some of these questions can be annoying. So I'll give you a few more minutes. So somebody tell me what the class width is.
Is it 4?
No, almost.
What about 5?
5. Class boundaries. I'll write the class boundaries down here. Class boundary is 19.5 plus 5 is 24.5, 29.5, 34.5, 39.5, and 44.5. That's your class boundaries. The class midpoints is going to be 22, 27, 32, 37, 42, and that's your midpoints. Now I'll take it over to the Excel spreadsheet. Y'all have to excuse my voice. Like I said, I think I got into too much pollen over the weekend. Let's go to the Excel spreadsheet. And let me go up here. And lower class limit, 20, 25, 30, 35, and 40. 24, 29, 34, 39, and 44. And 1, 2, 6, 8, 2. And you see, excuse me. Let's go ahead and that's going to be 19.5. And that's going to be, I'm not going to do all that over. Well, 24.5, 29.5, 34.5, 39.5, and 44.5. Midpoints 22, 27, 32, 37, 42. Okay, so the next thing you're going to do is write down your formulas for the mean and the standard deviation, which you should already have them. The mean of a frequency distribution is equal to the summation of f times x over summation of f, or the summation of f times x over n. And the variance is equal to n times summation of f times x squared minus the summation of f times x quantity squared, all that over n times n minus 1. And we're going to need n. We're going to need x. And we're going to need the summation and F is already given to us. So the only thing we need is x squared. And of course, I've already done that on the Excel spreadsheet. And here it is. There's F in green. The midpoint, X. There's x squared. That's not supposed to be there. Let's get rid of that. And there's F times X. And there's F times X squared, and I added them up. So all we have to do now is plug and chug into the formulas. So for, or mean, the summation of F times X is 648. And N is 19. So the mean should be 648 divided by 19. G8, which is 648 divided by 19. Somebody check and see if 648 divided by 19 is not 34.105. Somebody give me a thumbs up. Good job. Now you need to plug and chug into this formula. So that means N is 19. So 19 times the summation of F times X squared is right there, 22,566. Minus, and that's going to be 648 raised to the second power over 19 times 18. And plug and chug. And I've already done that right here for you. 19 times 22,566 minus 648 squared. And that's going to be 18 right here. And somebody check that math out for me, please. So everybody should be either writing or punching on your calculator, one of the two. Or watching YouTube. And we get, somebody get 25.877 and 5.087. Good. And that's it. That's 2.2, 2.3. How many questions? Golly, you got 5 or 6 test questions here. There's 3 test questions right there. There's 3 test questions right there. So you got about 6 in the blue. 6 test questions. And no questions? Okay. This is the only class I've got. Nobody has any questions. Wow. I guess just, what is it? Gifted and talented? Yeah, it's probably going to be to you because it's reading. There's no math involved in 2.3. It's just reading. And being able to look at pictures. Now, let's go to chapter 3. Chapter 3, which is pretty much 70 to 80% of your test. There's 2 or 3 things in chapter 3 that we're going to be talking about. I think 3.1 through 3.3, tendency of center. Which is your mean, median, mode, range, mid-range, variance, and standard deviation. Well, here we just did that. Well, not really. This is with data like test grades. We just did a frequency distribution. Now we're moving into what we call data, which is test grades, like test grades. And we also got z-scores in 3.4. I think 3.4 we actually talk about quartiles and box plots. And then in 3.5 we talk about z-scores and empirical rule. So there's chapter 3. Thank you, Ms. Vaughn. It says due September 6th at 11:59. So let's take an example. Let's say you got the following test grades. And I'm going to write them in order. That's one thing you got to do, make sure everything's in order. So 71, 75, 80, 83, and 90. So here's your 5 test grades. And you're going to take those 5 test grades, put them in order, which we did. And we want to find the mean. The mean is the summation of x over n. So, of course, y'all been doing your grades average, test grade average, since you were in the 7th grade. So go ahead and add those up and divide by 5. I'm going to go to the Excel spreadsheet. $71, 75, 80, 83, and 90. And that gives us the summation of 399. That's going to be 399 over 5. And that comes out to be 79.8. Everybody in here should be able to do that because you've been finding your test average since, like I said, the 7th grade. So everybody in here can do that. Median. What's the first thing you think of when you hear the word median? Well, most people think of the middle of the road. You know, the big cement barrier in the middle of the road, the median. It's the middle. Calculated middle. Based on n. If n is odd, you pick the middle number. If n is even, take the midpoint of 2 middle numbers. That's how you find the median. So since the n is 5, all we need to do is just pick the middle number, and the middle number is 80. So 80 is your median. Mode. What is the mode? Anybody know? It's a number that shows up what?
The most.
Good job. The most. And you can have more than one mode. Bimodal or monomodal, bimodal, trimodal, polymodal. So you could have more than one mode. Range is equal to the highest number minus the what? The highest number minus the lowest number. The mid-range is the middle calculated by the high and the low. The median uses the middle terms. The mid-range uses the extreme terms. And if you go back to the problem, go ahead and find all those. I want you to find them by hand. I want you to find the median, the mode, the range, and the mid-range. And check them with my numbers over here. What happened to, we missed somebody. Who left? Oh, no, we didn't. No, we didn't. I'm sorry. Thought somebody left. Let me know if you got all those numbers from the mean to the mid-range. Yes or no? Okay, which one you need help on? If you need help, just ask. I have all but the mid-range, okay? Good? Yes, no, maybe? How do you find the mid-range? The high number plus the low number divided by 2. It's the middle, it's the midpoint. Just like you'd find the midpoint of a class. The lowest number plus the highest number divided by 2. So in your case, that would be 71 plus 90, 90 plus 71 over 2. And here's your numbers. Everybody good? Yes, no, maybe? Got a couple of thumbs up. Thank you for communicating. Thank you. So now we do the variance. Summation of x minus x bar, quantity squared over n minus 1. And what is the relationship between the standard deviation and the variance? Standard deviation is always the what of the variance? Square root, Hubert. Or you could raise the variance to the 1/2 power, or you can raise it to the 1 or the 0.5 power. So all you got to find is the variance. There is the formula for the variance. And there is the formula for the standard deviation. Square root, you're right. Y'all know y'all not supposed to communicate with me. It's supposed to be the creed of the class not to communicate with Hubert. So, what does this mean? What am I going to subtract from each number, from each test grade? What am I going to subtract? Well, what is x bar? That's the mean, right? So I'm going to subtract the mean from every x. I'm going to square that number, and then I'm going to add them all up. So I'm going to take, I never forgot my numbers. Here we go. I'm going to take 71, and I'm going to subtract the mean. 75, subtract the mean. 80, subtract the mean, which is 79.8. 83 minus 79.8, and 90 minus 79.8. And that's going to give me a number, and I'm going to square that number, and then I'm going to add them all up. And that's what I did right here. So 71 minus 79.8 should be 8.8 negative. And I squared that number. So write that down. Write those 3 columns down, because that's how you do it by hand. Now, who's got a question on that? You add them all up, and that's 214.8. 214.8 is right here. And 5 minus 1 is 4. So that is your variance. Very difficult teaching a class that don't communicate. So it is appreciative, those that are communicating. Thank you. And I love the foreheads. I'm going to start calling this the forehead class. So 214 divided by what? 4. See if you get 53.7. 214.8 divided by 4. Y'all get 53.7? And then take the square root of that. 7.328. Now, what is the standard deviation? If I was to ask you to define the standard deviation, can anybody tell me what it stands for?
Isn't it like how far your original numbers are from the mean?
Good job. I am impressed. It is the spread. Just like he said, the spread. If the spread is large, that pretty much means the error is large. If the spread is small, that means the error is small. I'll show you what I mean. I want you to keep your eyes on the mean. I'm going to paint it yellow. The median and the mid-range. Also, keep your eye on the standard deviation. All right, everybody see those numbers? Watch what happens when I change the grades. Let's say I make a 71, 70, a 72, a 73, and a 75. Tell me what happened with these numbers over here. There's two things I want you to see about these numbers. What happened to one set of numbers and what happened to the other number when I changed those numbers to 71, 70, 72, 73, and 75? What happened over here? What went down?
They all changed.
Well, they all changed. Oh, yeah, that's true. But what happened to these three yellow numbers, and what happened to this number at the same time?
The standard deviation went down.
The standard deviation went down because the numbers are closer what?
Together to the mean.
So what happened to the measures of center? They got closer to each other, didn't they?
Yep.
Let's go back. Let's go back. All right, everybody see the numbers? 79.8, 80, 80.5, and 7.3. Everybody see that? Look what happened to the standard deviation. It went from a 7 to a 2. And these numbers got closer, what? Together. So let's change it to something really different. Let's say that the first week of class you were loving life. You didn't have any DAs to hang around, bad influences. So you had a 100 on your first test. Then you started hanging around DAs and you went down. Then you got away from the DAs and you had another 100. What happened to the standard deviation? It shot up to double the first group. Why? Because you got some weird numbers over here. That's how a teacher can look at your grades and say, what the hell? And they have some idea that something is going on because they're not lining up. Look at the mean, the median, and the mid-range. What happened to them? They're all over the place, just like your grades are. So your grades can say something about what's going on with you, especially if they're all over the place. But let's change that back to a 70 and change that back to a 75. And you see the mean, the median, and the mid-range are all around 72, and this dropped down to a 2 instead of a 15. Can the numbers tell you things? Yes. Okay? So make sure you understand what standard deviation is. Standard deviation basically tells you if the numbers are tight or if they're all over the place. Again, let me throw a 100 in here. And let's throw a 95 down here. What does the number tell us? Well, that standard deviation went up to a 14. And these middle numbers, they don't match. See? And you always thought you were just finding the mean and the standard deviation. What you're finding is what tells you what's going on with the numbers. Okay? So, where does this go? Well, I'm going to go ahead and get the cart before the horse, and we're going to talk about the empirical rule. This is a test question, and it's going to be following us throughout the whole semester. So you need to write it down. I don't know what page it's on. Look in your book if you got a book or ebook if you're looking at it, and tell me. I think it's in 3.4, but I may be wrong. Now I go through the internet and I basically pull up a printout of it, so I don't have to draw it over and over and over. You're not going to be able to see this very well. But there is the empirical rule. That's the empirical rule. Now what I'm going to do is I'm going to pull up the e-text and show you how to draw it with the e-text. So let me get there first. Anybody seen it in chapter 3 yet? Oh yeah, that's right. You're not going to tell me. Good. It's in here somewhere. Hold on. Am I in the wrong book? I'm in the wrong freaking book. I hate life. I'm in 109. I suck. Let's go to 120. Sorry about that. 120.23. You probably saw it in probability and statistics. Where's the e-text? There it is. Chapter 3. And I think it's in 3.3 or 3.4. Oh, you haven't? Wow. Okay. Probably in 3.4 then. I'm looking for it. And I'm not finding it. What page am I on here? 151. Maybe 3.5 then. Let me just keep going until I get there. I'm thinking it's 3.3 now. Yep. Let me go to 3.3. 3.3. Three 3.2. Let's try 3.2. Oh well. I know I saw it somewhere in chapter 3. I just don't. There it is. Thank you. Page 129. Write that down because I know some of y'all are not going to draw it because too lazy. Mr. Linker, are you still with us? Thank you. So here is the drawing. Go ahead and draw it if you want to draw it. Now you can go to the internet and pull up the empirical rule. Oops, sorry. This is not only going to follow you throughout the semester, this is also several test questions. So I would, if I was you, I would find a nice one on the internet, like I have right here. Right here. And I would make copies of them because you're going to be drawing them left and right. Here's one that I made bigger. And here's one, of course, you see that one. And the reason I've done that is because I don't want to draw them over and over and over. Now, I do realize that most of y'all aren't going to do that, but I thought I'd mention it to you anyway. Go to the internet, pull up empirical rule with percentages, curve, and it will pull up several. I'll go to it right now and pull it up. Empirical rule curve, and you could put that. Hit images, and there's plenty for you to copy, paste into a word processor, make copies, and you won't have to draw it every single time. Now, there's some of you that you're not going to have to draw it because you already know everything. And then you'll cry when you get it wrong. So make sure you got a good understanding of the empirical rule. A good understanding of the empirical rule is 95%, and write this down, 95% of the population will fall between two standard deviations. And you see that right here. Well, I can't highlight it, but there it is. %, within two standard deviations. Now, how did I use this thing? Well, in order to use the empirical rule, you have to have the mean and the what? And the standard deviation. Write that down. In order to use the empirical rule, you have to have the mean and the standard deviation. That's why the mean and the standard deviation is so important. So make sure you draw the standard deviation. Now, this is what you should be able to do with the empirical rule. And I wish I had a bigger, here's one. I got one. Everything is all over my table here. There we go. Here's the one I use to show students. There it is, and it's on the internet. That's what I tell students to use for a big one. And you put your mean in the middle. That last problem we did. Let me find it. Where is the Excel spreadsheet? The mean is 82. And the standard deviation is 14. So you would take that mean and standard deviation, put the mean in the middle, 82, and then you would add standard deviations on the right. So 82 plus 14 is 96. 96 plus 14 is what? 110. Y'all check my math. And 110 plus 14 is 124. 82 minus 14, I have no earthly idea. I would say what? 68? I suck at subtraction. 68? 68 minus 14 is what? 54? And 54 minus 14 is 30 or 40? 40? Y'all check my math, please. So now you can shade in what you need to shade. What do you mean, Hubert? Well, 95% of the population is going to fall between 54 and 110. "95% of the population is going to fall between 54 and 110. Can somebody tell me what is outside of the normal within this standard deviation? Anybody? Anybody that's had probability before, maybe?
Yeah, I think it's called unusual
Good job.
and highly unusual further.
Highly unusual has a word for it. Starts with an O. U T L I E R S. Outlier. Outlier. That's your Tiger Woods, your Peyton Manning, your Tom Brady, your Michael Jordan. That's your outliers. Your 6 foot third graders. Shaquille O'Neal. I mean, how tall is he? 7'4" or something like that? He's huge. Okay? Outliers. People that can play Beethoven's Fifth at 5 years old. People that make a 1600 on the SAT. They're outliers. People that fit in this area, they're just unusual, which is, you know, somebody that can, I don't know, score a big high score on the ACT, but not the highest. But most of us kind of fall in here where we're what? Normal. Hey, how are you? Y'all ever seen SpongeBob episode where he's normal? And Squidward is normal? Hey, how are you? There is a teacher at the Anderson campus. When you walk by him and say hello, he'll go, hey, how are you? Just like that. Yep. Hey, how are you? I'm not that way. I may not be a Michael Jordan or all of that, but I ain't normal, okay? There's some aspects of me that ain't normal. But most of the time, when it comes to, you know, just regular stuff, I'm normal. But I guarantee you, I'm the only teacher at Tri-County Technical College that has his own bulldozer, track loader, track hoe, and backhoe. I guarantee you, I'm the only one. So, in one way, I'm not normal. And I'm in all of Ron Rash's books. So, I'm not normal that way. Okay? And that is the empirical rule. So, when you're doing a problem and you get blah, 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 what is the mean and standard deviation? And then it asks, what is a score of 106? And that's the type of test question you're going to get. Find the mean and the standard deviation, and then it's going to say, what is a score of 106? Normal, unusual, or an outlier? It's not that hard. Just somebody say, it's either go, you got a 33% chance.
It's normal.
Thank you. Hi, how are you? It's normal. And don't act like y'all don't watch SpongeBob. I know some of y'all still watch SpongeBob, so. Because my son and my daughter still watch SpongeBob. And my favorite two characters are Plankton and Squidward. I think Patrick Star should be beat with a bat. Because nobody is that stupid. Nobody. That's how you do empirical rule. Is this something that you're going to do throughout this whole semester? Yes. You're going to do it with mean and standard deviation. You're going to be doing it with z-scores. You're going to be doing this, so you better go ahead and print out some copies, because I think there's only one unit that we don't do this, and that's the second unit when we talk about probability. After that, we're still going to go back to the curve. So you better learn how to do it. Question, gripe, complaint. Okay, well, how do we do a box plot and 5-number summary? Well, let's take an example. Let's do an example. And let's do average ages of people in the class. 17, 17, 18, 18, 18, 19, 24, 26, and 30. Okay? Not your class. Everything doesn't revolve around you. I'm talking about a class. Okay? So here is a class of 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is odd, so you just pick the middle term. There's your median. Now I want you to go ahead and find all the other stuff. I want you to find mean, median. We already found it. 18. Mode. What's the mode? Somebody tell me which one is the mode, 17 or 18? That's called a Q.
18.
I'm wanting somebody to say something.
18.
Thank you. Mean, median, mode, range. Well, 17, that's 13, so. Mid-range. 17 plus 30, that's 47. Oh, gosh. Excuse me. 26 and a half, 26.5. Somebody check my math, please. And somebody give me the mean. What is the mean? Add those up and divide by 9.
I got 20.7 repeating.
20 point what?
7 repeating, so it's 0.78.
20.78. Okay, find the mean, find the variance and the standard deviation. So I'll go over to my spreadsheet and make up a new spreadsheet, because we got more numbers here. So So 17, 17, 18, 18, 18, 19, 24, 26, and 30. So I'm going to go over here and check our average. X bar is equal to the summation of all those numbers divided by 9 equals that number divided by 9. Yes, it does come out to be 20.78. What is it? Okay. And I'm going to subtract that from each one of these, because this is x, and this will be x minus x bar. So equals 17 minus that number, F4. I'm going to copy that down. Y'all check y'all's numbers. And then I'm going to square that. And that's going to be this number raised to the second power. Copy that down. Add that up. And the mean, or sorry, the variance is equal to that number divided by 8. Equals that number divided by 8. And then the standard deviation is equal to that number raised to the 0.5 power. So you would take your handy dandy empirical rule, and I've got a mean of 21 and a standard deviation of 5. I'm rounding up, so I don't have to deal with those decimals. Of course, if the book tells you, or the directions or the test tells you to round the mean to the 10th, then you would round that to the 10th, and you would add and subtract those decimals. But since I'm the teacher and since I'm showing you how to do this, I'm going to make it whole numbers. So there is my, I'm going to put a 21 right here, and 26, and 31, and 36. 21 minus 5 is 16. 16 minus 5 is 11. 11 minus 5 is 6. So I take my handy dandy green marker, and between the ages of 11 and 31, that is considered to be normal. Unusual is going to fall right in here. And outlier be right here. So we're talking about a history Western Civ class. What's the chances of a 40-year-old or a 5-year-old being in a Western Civ class? About 0, because they're outliers. And that's how you use standard deviation. Now, what about quartiles? I told you about quartiles. Let's go back. Here is the median. 18 is the median. I'm going to show you the quartiles. There's the mean, the first quartile, the second quartile, the third quartile, and the max. The mean you already have, 17. The second quartile you already have, 18. The max is 30. So you already got 3 of them right there. If you miss the mean, the second quartile, and the max, then I can pretty much ascertain that you're going to be in a bad office. It ain't going to be, your future is not very bright. All right, be careful. All right, so there's the mean. And here's the max. So how to find the first quartile? Well, the first quartile is the median of these 5 numbers. So it'd be 18. So there's 1, 2, I'm sorry. Yeah, there's 4, so it'd be these 2. And there's 4 over here. So 17 plus 18 divided by 2, and 24 plus 26 divided by 2. So 17 plus 18 is what, 35? So that's 17.5. And 24 plus 26 is 40. Half of 40 is 20. Now I'm going to show you how to do a box plot, because you don't have to do anything now because you've got what you need for the box plot.
Mr. Mickler,
I'm sorry, say again?
24 plus 26 is 50, not
It's 50.
40.
Okay, 25. I'm sorry. Thank you. 25. Make sure I did this one right up here. 25.
You did do the first quartile, right?
Okay, so here we go. This is how you do. Also, the first quartile is also called the 25th percentile. And the second quartile is also called the 50th percentile. And the third quartile is called the 75th percentile. Just in case you see it on a test, or they're the same thing. It's like reading a fuel gauge. 0 is empty. And what about right there? That's 25%, or what? Quarter of a tank. What's in the middle? Half a tank. Three-quarters of a tank. And what? Full. So when you're thinking about quartiles, you're thinking about, quarter of a tank. What's the number that represents the 25th percentile? What's the number that represents the 50th percentile? What's the number that represents 75th percentile? So this is what you do. First thing you do when you draw a box plot is you draw a line. And that line is going to consist of 3 numbers at first. The min, the max, and we haven't got one of them. We got to calculate it. The mid-range. Oh, there it is. 26.5. So the first thing you do is you draw a number line. Number one, draw a number line with the min, the max, and the mid-range. Number two, graduate the number line. Well, 17 to 27 is 10, half of 10 is 5, so that's going to be 22. Half of 10 is 5, that's going to be 31. 17 to 22 is 5, half of 5 is 2, it's 19, 24, 27, or let's say 27 would be 29, and 33. I graduated it. And number 3, plot. What do I plot? Well, this one says 17.5. So 17.5 is right in here. It's purple. Orange is 25. 25 is right in here. And blue, I got blue. I used all my colors, darn. I gotta use something else now. Let's go with a aqua color. No. Let's go with a brown, bronze. And that's gonna be, 18, yellow. 18 is right in here. And there's your box plot. And that's how you do the 5-number summary in the box plot. Excuse me. At least I'm not, don't sound like I got, I smoked 2 packs of Marlboros a day. That's the COVID. I got sinuses. I don't have allergies. I don't have COVID. COVID, you have freaking coughing like you coughing up a lung. All right. So what did I just cover today? I finished covering the mean all the way through the standard deviation of a frequency, a quantitative frequency distribution. I basically covered 3.1 through 3.3, which is data mean through the standard deviation. And I covered frequency distribution, empirical rule. And I covered 5-number summary and box plot. I think 5-number summary and box plot is 3.4 or 3.5. I really don't know. So the only thing we got left is z-scores. But I know y'all gonna send questions because some of y'all are gonna have to send questions. Some of y'all are, unless y'all are all, invented the book and invented statistics. Okay, and that takes care of everything. So y'all should be moving on to 3.3, and I don't know where the 5-number summary is. Hold on, and I'll tell you. Maybe it says it in the. There it is, 3.5. We just did 3.5. So 3.4 is left. 3.4 is left. All right, I'm gonna shut down the share and shut down the recording.